Welcome to the DIY Honda Garage channel. The DTC P0121 indicates that the throttle position TP sensor A is out of its expected range. This error typically arises within Honda vehicles, particularly the Honda Pilot models from 2016 to 2022. The TP sensor plays a crucial role in determining the position of the throttle plate, thereby controlling air intake and consequently engine performance. Located between the throttle body and the engine control unit, ECU, any malfunction can lead to significant power loss and erratic vehicle behavior. Correctly diagnosing and resolving this issue is critical for maintaining optimal vehicle functionality and safety. DTC P0121 signifies a fault where the TP sensor A is reading outside its normal operating range. This sensor is situated within the throttle body, which is responsible for regulating air intake to the engine. The proper functioning of the TP sensor is paramount, as it directly influences the throttle plate movement, adjusting airflow according to engine demand. When the readings drop below 0.38 volts or exceed 4.50 volts, the vehicle's engine control module, ECM, flags this as a problem. This condition can lead to performance issues, including stalling or reduced acceleration, making it vital to address promptly. There are several potential causes for the P0121 DTC, which include a faulty throttle body, sensor connection faults, and wiring issues. A defective throttle body can provide incorrect throttle position information, leading to miscommunication with the ECM. Poor or corroded sensor connections may also disrupt the signal, causing the ECU to register erroneous readings. Furthermore, both open and shorted wires in the throttle position sensor circuit, such as the THL1 or VCC5 lines, can lead to an out-of-range signal. Lastly, if the powertrain control module, PCM, itself is malfunctioning, it may misinterpret the data from the TP sensor, thereby flagging this error. Symptoms associated with DTC P0121 often manifest through noticeable changes in vehicle performance. Drivers may experience significant loss of power during acceleration, as the engine struggles to receive the appropriate air-fuel mixture due to incorrect throttle readings. Additionally, the vehicle may stall during operation, particularly when idling or transitioning between speeds. Furthermore, a persistent check engine light will be illuminated on the dashboard, alerting the driver to the ongoing issue. These symptoms point towards a need for immediate diagnostic evaluation to prevent further complications. The first troubleshooting step involves verifying the problem by interacting with the vehicle's ignition system. Start by switching the vehicle to the on state, ensuring all electrical components are powered. Use the Honda Diagnostic System, or HDS, to clear any stored DTCs, which resets the error conditions. Following this, turn the vehicle back to the off state, locking it to complete system initialization. Turn the vehicle on once more and utilize the HDS to monitor the values for TP sensor A, specifically checking if they drop below 0.38 volts. If they do, it confirms a recurring fault, leading to the next troubleshooting phase. In this second step, continue using HDS to assess the voltage readings of TP sensor A. Specifically, you want to check if the readings exceed 4.50 volts. If they do, this suggests a persistent fault that needs to be addressed in the upcoming steps. If the voltage is in the acceptable range, the problem may be intermittent, indicating potential poor connections at either the throttle body or the PCM, powertrain control module. If applicable, refer to the onboard snapshot data to reproduce the failure under similar conditions. This diagnosis is crucial for understanding whether the issue is sporadic or a consistent malfunction. Verification of additional DTCs is vital in this troubleshooting step, where you will assess whether DTC P0221 is also indicated alongside P0121. Ensuring a comprehensive diagnosis can highlight interconnected issues that might be setting off multiple error codes simultaneously. If both P0121 and P0221 are present at the same time, it signifies a problem that could be rooted within the same circuit. This step serves to narrow down the focus on components that may rely on similar wiring or connection pathways. Based on these findings, the next troubleshooting step will direct you to investigate more specific wiring or component failures. This step focuses on checking for shorted wires within the throttle position sensor circuit. Begin by turning the vehicle to the off position and using the HDS to jump the SCS line for diagnostic purposes. After waiting for more than 1 minute, disconnect both the PCM Powertrain Control Module Connector B and the throttle body connector. The next crucial step is to test for continuity between specified test points: the throttle body connector and body ground. If continuity is present, it indicates a short in the THL1 wire leading to a clear path of electrical current. Repairs should then focus there. Conversely, if continuity is absent, it may point toward other sets of issues needing exploration. For this step, first ensure the vehicle is turned off. Proceed to disconnect the throttle body connector to allow an uninterrupted voltage test. Switch the vehicle to the on mode without starting the engine, which activates the electrical system while allowing for proper voltage measurement. Utilize a multimeter to measure the voltage at the designated test points on the throttle body connector. The goal is to confirm if the voltage reads approximately 5.0 volts. This is indicative of a functioning throttle body. If the reading is correct, the next action should be replacing the throttle body, as this can resolve the DTC. If not, further investigation into wiring or other components will be necessary. This troubleshooting step delves into checking for any open circuits in the VCC5 wire. Start with the vehicle in the off state. Jump the SCS line with the HDS and maintain this configuration for over a minute. Disconnect the PCM connector to evaluate the wiring system without interference from the module. After disconnecting, test for continuity between the throttle body connector and the corresponding connector on the PCM. If continuity is confirmed, it indicates the VCC5 wire is functioning correctly, allowing you to move on to possible issues within the PCM itself. If no continuity is detected, the VCC5 wire needs repair due to an open in the line. At this stage, you are reassessing the vehicle to confirm the presence of any additional DTCs, particularly P0221 alongside P0121. Conducting this check allows you to gauge whether multiple errors are occurring simultaneously, possibly indicative of a larger systemic issue. If both DTCs are present, further testing will be directed towards the throttle body and associated wiring. Otherwise, focus will shift to other components involved in the DTC signaling process. Understanding these connections can help isolate the root causes and streamline the troubleshooting process, making it more effective for a resolution. Revisit the check of voltage readings at the throttle body connection, which will shed light on the condition of the throttle body itself. After confirming the vehicle is in the off position, disconnect the throttle body connector to prepare for testing. With the vehicle switched to the on mode, measure the voltage across specified terminals in the connector. If the readings approach approximately 5.0 volts, this indicates that the throttle body is indeed faulty and will need replacement to restore functionality. Should the voltage deviate from this expected range, additional investigations into wiring or other controllers will be necessary. Continue evaluating the integrity of the THL1 wire to ensure there are no open circuits affecting performance. First, ensure the vehicle is turned off before jumping the SCS line with the HDS and waiting for a minute. Disconnect the PCM connector to isolate the system for continuity testing. Then, assess continuity between the throttle body connector and the PCM's designated terminal. If continuity exists, it suggests that the THL1 wire is functioning without issues. You should then examine the PCM further. If there is no continuity, that would confirm an open circuit, necessitating repair of the THL1 wire to restore proper function. In this last step, you will be confirming the state of the SG5 line for any open circuits that may be impacting sensor performance. Begin by switching the vehicle to the off position, then jump the SCS line with the HDS. Disconnect both the PCM and throttle body connectors, isolating them from the circuit. Check for continuity between the throttle body connector terminal and the corresponding terminal in the PCM. Should continuity be detected, this strengthens the case against major wiring issues, enticing a focus on testing with potentially known good PCM replacements. Conversely, if continuity does not exist, repairs will target the SG5 wire for an open circuit. As you reach the final step in the repair process involving DTC P0121, your primary goal is to affirm that the issue has been effectively resolved. Begin by retesting the system to ensure that all components involved in the throttle position sensor circuit are functioning correctly. Make sure to monitor the voltage readings closely and check that they are within acceptable thresholds. Following resolution, keep an eye on the system's diagnostics for any reoccurrence of DTC P0121. This methodical approach not only ensures the initial problem is addressed, but also bolsters the longevity of the fix undertaken. Preventive maintenance is key to prolonging the life of your vehicle's throttle system and avoiding future issues related to DTC P0121. Regular inspections of the throttle body and related components can help catch problems before they escalate. It's essential to frequently check electrical connections for signs of corrosion or wear, which can disrupt signal integrity. Additionally, protecting these components from moisture exposure will further mitigate the risks of future failures. By adhering to these preventive measures, you can enhance the reliability of your Honda Pilot and ensure a smoother driving experience. In conclusion, addressing DTC P0121 effectively requires a systematic approach that begins with understanding the root cause of the TP sensor A error. Thorough diagnostics are essential, examining both the wiring integrity and the functionality of components like the throttle body and PCM. The interrelationships between these components must be carefully considered as they can exacerbate the issue. Implementing preventive measures can significantly extend the lifespan of these systems, thereby enhancing performance and reliability. Ultimately, addressing these concerns promptly saves time and money while ensuring the safety and comfort of your driving experience. Please like and subscribe to the channel. See you next time.